All right, class, we'll look at the next section in this unit, some difference in double angle identities. So here's some further identities from the ones that you already have. So you have a whole list of these identities. So let's start to use these now. Okay, so we'll get into example 1 here. So what you basically have to do with these type of questions is look at the identity that you have, and this includes what we looked at previously in this unit. Okay, so you have to kind of, it's a good idea if you can kind of, on a separate sheet of paper, compile all the identities on one page so that you have kind of easy access to them. So here, if you look at this pattern, what it basically is cosine A cosine B equal to, cosine A cosine B plus sine A sine B. Right, see, that's the pattern that you see in the question, and according to the identity, this is equivalent to cosine A minus B. Okay, and so all you have to do here is go cosine 88 minus 35, which equals cosine 53. Okay, and you can leave your answer like that, because the question says to express your angle as a single trigonometric function. Okay, it doesn't matter if you're degrees or if you're radians, same idea. Here, you've got 2 sine A cos A. Okay, now, oops, I put the A there. It would not be valid if the two angles were different. Okay, then it wouldn't be sine A cos A, right? So that's saying that they're the same. And so this basically simplifies to sine 2A. And so that's going to equal sine of 2 times pi over 12, which is going to equal sine pi over 6. Okay, and again, you can just leave your answer like that. Okay, now we kind of got into algebraically simplifying expressions or converting them to other expressions in the previous lesson. Here's another example of that, so just using the identities. What they want you to do here is find the identity for cos 2a and then change it so it only has sine ratio inside of it. Okay, so let's look at what the cosine 2a is. Okay, so again, if you're wondering where I'm getting these are from the list of identities. Okay, so this is going to equal cos squared a minus sine squared a. Okay, and so now what we'll do is we'll use the previous identities, and so the previous identities, some of them that we looked at were the Pythagorean identities, so that was where we had cos squared a plus sine squared a equal to 1. And so here cos squared a is going to equal 1 minus sine squared a. Okay, so what I did here is I took the Pythagorean theorem identity, and then I just isolated for cosine. And so now what I'm going to do is I'm going to take this one here, 1 minus sine squared a, which is equal to the cosine squared a, and I'm going to substitute that in for the cosine. Okay, and the reason why I'm doing that is because I want to change this expression so it only includes sine, and so this is going to be 1 minus sine squared a minus the sine squared a over there, and then you get an answer of 1 minus 2 sine squared a. Okay, so you took the original expression that had the cosine and you've changed it to one that only has sine. Okay, let's look at some more here. So we talked about this last class, non-permissible values. And basically those are the ones that are excluded. And so the other way to look at it is everything aside from them are permissible values then, right? And so here, what we want to do is look at the bottom of this fraction, and basically this expression is going to be undefined when cosine 2x plus 1 is equal to 0. Okay, so then it becomes undefined. And so what we can do is we can take the cosine 2x and change that to, use one of the identities there, and change that to cosine squared x minus sine squared x. Okay, and then the plus 1 equals to 0. And then what you can do is, just like we did in the previous example, we can, it doesn't matter which one you want to change here, but let's say we want to get rid of cosine squared x. So this one here will substitute for cosine squared x 1 minus sine squared x. Okay, minus the other sine squared x plus 1 equal to 0. And so what that's going to give you, when you collect like terms, it's going to give you 2 sine squared x equal to 2. And so that means sine squared x is going to equal to 1. And then if you take the square root of both sides, you get sine x equals plus or minus 1. And then when you solve for that, you're going to get x equals pi over 2 and negative pi over 2. Okay, if we're using radians, or if we're not using radians, that would correspond to 90 degrees and negative 90. And so if these are non-permissible, so I'll write this down as x can't equal those values, because those values cause the bottom of that fraction to be equal to 0. Okay, and now let's do some more algebra. Okay, so what it says here is simplify the expression to one of the 3 primary trigonometric ratios. The primary ratios would be sine, cos, or tangent, not the cotangent, secant, or cosecant. Okay, so one of those 3. So take that expression and convert it to one of the 3. So again, with I made a mention of this on the previous lesson. I need to see your steps in how you go about doing this. Okay, so let's write out the question again, or actually we can just go ahead and convert that. Okay, so sine 2x at the top. Again, if you're wondering where I'm getting these from the identities. Sine 2x is going to be equal to 2 sine x cos x. And then the cos 2x is going to equal the cosine squared x minus sine squared x. And then you still have that plus 1 there. Okay, so that was cosine 2x, switching to cosine squared x minus sine squared x. And then again, what we can do is we can get rid of one of these, and so we can make that 2 sine x cosine x, and we can get rid of that cosine, the cosine squared x again, using the Pythagorean identities, and change that to 1 sine squared x. Okay, so that's the cosine squared x changing to 1 minus sine squared x, and then you still have the minus sine squared x plus 1. Okay, and then what happens here is you're going to get 2 sine x cosine x over 2 minus 2 sine squared x. Okay, and so what you can do here is you can factor out the 2 on the bottom. So that's going to give you 2 sine x cosine x over 2 1 minus sine squared x. Okay, and so what happens here is the 2's cancel out, and then you get sine x cos x, and that 1 minus sine squared x, that's equivalent to cosine squared x. And then what happens here is the cosine, one cosine at the top gets canceled out, and the cosine squared at the bottom just turns into cosine. And then sine over cos, that's equal to tan x. Okay, and that's your answer. Now, just a word on this. The methods, the steps I'm going through, there's multiple steps that'll get you to the same answer at the end. Okay, so it's not like there's only one sequence of steps that'll get you here. And sometimes what happens is, as you're doing this, you'll kind of add in redundant steps, but don't worry about it if it kind of takes you back to something else, as long as at the end you can get to your final answer. Okay, so again, there isn't one set of sequences that'll get you to the final answer. But again, I want to make sure that you're showing all the steps to get to the answer. So a question like this, if you just wrote down tan x, I want to see how you got there. Okay, so that wouldn't be what we're getting to here. This is almost the same thing as when you do proofs. So when you're trying to show how one thing is something else, you need to show the steps that support that. Okay, and now let's get into something a little bit different here. So what we're going to look at is taking values, so actual numbers now, angles, and then trying to work them out to using the identities to get to a more simplified answer, or in this case, what we're trying to do is get an exact answer. Now, the good thing about these type of questions is after you go through all these steps, you can use your calculator to confirm that your answer is correct. Okay, so let's look at the first one. So now you've got 165 degrees. Basically, if we're trying to find exact values, what you want to do is break that big angle up, either in terms of an addition or a subtraction that's going to involve your special triangles. Okay, so remember your special triangles is this 30, 60, 90 triangle, and also the 45 triangle. And so, and remember, you can still have a 60-degree angle in a different quadrant, or a 30-degree angle, or a 45-degree angle in a different quadrant. So they don't have to literally be 60, 30, or 45. Okay, and so this first one kind of shows that. So I can take cos 165, and let's say I want to do an addition. I can change that to cos 120 plus 45. Okay, so what you're trying to do is it should add up to 165, and the angles I've selected here, the 45 is a special triangle, and the 120, because it's in quadrant 2, that gives you 60 degrees left over. Okay, so it becomes a special triangle in quadrant 2. Okay, so let me just show what the triangles are. So for that 120, this is going to be 60 degrees, 90, and 30. And then that's going to give you negative 1/2. Okay, because it's negative because your x is to the left. Root 3 over 2 and 1. Okay, and then your 45 is going to be 1 root 2 over 2 and root 2 over 2. Okay, so this is what I mean special triangles. And so these now I'm going to use first. Let's write out what this expression is equivalent to. So now using the identities, this is going to be equal to, so this is like your cos A plus B. Okay, so this is going to be cos A plus B is going to equal cos 120, cos 45, and then minus sine 120 and sine 45. Sine 120 and sine 45. Okay, and then that's going to equal negative 1 over 2. Right, so cos 120 is that 60-degree angle in quadrant number 2, and so that's going to equal to x, so that's where I get the negative 1/2 from. Cos 45 is going to equal root 2 over 2. And then this is going to be minus sine 120, which is going to be root 3 over 2. And then the sine 45 is going to be root 2 over 2. Okay, so this is going to work out to negative root 2 over 4 minus root 6 over 4, which you can combine to minus root 2 minus root 6 over 4. Okay, and that's your final answer. Okay, so that's what we mean by an exact solution. Okay, so you need to do that. But what I'm saying is you can use your calculator. You can figure out what cosine 165 is on your calculator, and then you can work out minus root 2 minus root 6 divided by 4, and it should give you the same answer. So at least that way you have some confidence in knowing you got the correct answer. Okay, let's look at another one here. So this is a tangent. So now instead of degrees, you're using radians. But it's the same thing. You want special triangles involving radians. And so if you're unsure of what's 45 or what's 30 and 60 in radians, then just find the corresponding radians from those degrees, right? So meaning take 30 degrees and convert it into radians. Okay, and same as the previous one, it doesn't have to be in quadrant 1. It can be in any of the 4 quadrants. So what I'll do with this one is I'll make this tan 9 pi over 12 plus 2 pi over 12, which is going to equal, if I put this in lowest terms, 3/4 pi plus pi over 6. Okay, so if you're wondering what is that, 3/4 pi I think is 135 degrees, so that'll give you that 45 in quadrant 2, and pi over 6 is 30 degrees. Okay, so that'll give you the 30-degree triangle in quadrant 1. Okay, and so if you're unsure what the dimensions are, do what I did with the previous one. Just draw the triangles using your grid, and then you'll see where your exact values show up. Okay, so now we've got our sum identity there. That's going to be equivalent to. So again, I'm getting this from the table of identities. This is going to be 3 pi over 4 tangent plus tangent pi over 6 over 1 minus tan 3 pi over 4 and then tan pi over 6. Okay, so now that you got that, work out what each of those are. And what you're going to get here is you're going to get, so 3 pi over 4. So that's the one in quadrant 2 that has the 45-degree angle. So remember, tangent's opposite over adjacent. So this is going to be root 2 over 2 divided by negative root 2 over 2. Okay, so opposite over adjacent, plus 1/2 over root 3 over root 3 over 2. Okay, so that'll be the top part of the fraction. The bottom part of the fraction will be 1 minus root 2 over 2 divided by negative root 2 over 2. And then 1/2 over root 3 over 2. Okay? So that's, I mean, now, you know, it's a lot of algebra to get to the final answer. So if we start at the top here, we get negative 1 plus 1 over root 3. Okay, and that's over 1 minus negative 1 and 1 over root 3. And so what that's going to give you is 1 over root 3 minus 1 over 1 plus 1 over root 3. Okay, and so now what you want to do is you want to combine into a single fraction. So the top fraction is going to be root 3 minus 3 over oh, sorry, I missed a step here. So what you want to do after you get to this step here is what you can do is let's rationalize the denominators, okay? So that first fraction at the top, that's going to be root 3 over 3. Okay, so I just rationalize that. And then we can combine that with the minus 1, which will just be minus 3 over 3. And then the bottom, it'll be 3 over 3, so that's 1, plus root 3 over 3. Okay, and then when you, what you want to do now is, let's combine this to a single fraction. So this is going to equal root 3 minus 3 over 3 over 3 plus root 3 over 3. And then what you can do is you can, it's a division, so you can multiply by the reciprocal. And so what this is going to be is this is going to give you after you multiply, this is going to give you root 3 minus 3 over 3 plus root 3. So basically the 3's cancel out. Now don't leave it like that. What you want to do is you want to rationalize the denominator, and you can do that by multiplying by the conjugate. So multiply the top and the bottom by the conjugate, which is 3 minus root 3. And so after you multiply by the conjugate, you rationalize the denominator, you're going to get 6 root 3 minus 12 over 6. And so your final answer here is going to be root 3 minus 2. Okay, so again, there's your exact solution. So that's a pretty complex question. right? It involves lots of steps. Okay, so again, don't just write the final answer. Show me how you get to there. Okay, so now you can work on the corresponding questions for this section.